Can all hear me? I hear. Actually, I hear the echo, so. Okay, good morning. Finally, we're getting started 3 minutes after the assigned time. But that's okay. We have a whole hour. My name is Nikolai. I work for a company here in Oslo called Beck. Well, here in Norway, we have an office in Trondheim too. And I'm here to talk about this. First, just very easy about what F# make is, because it's in the title, and I feel I kind of have to maybe explain where I'm going with this title, because it's a bit buzzwordy. And yeah, well, fake is what we all know from long time ago about make files and everything. It's a build automation utility. And what that basically means is just a tool for enabling build automation. And this is just taken straight from Wikipedia and just like explains what build automation is. And the reason we use build automation is because we want documented builds, and we want reproducible builds, and we want our build to return some kind of artifact that we can use. I'm using the word immutable, but we want the build to be reproducible, and we want the artifact to, when it's done, to be immutable. We don't want to change it later. And that's why I'm in the title saying like immutable deployments or reproducible deployments. Because the goal here, and what I'm going through in this talk, is about achieving the same for our deployments as we are for our builds. And the reason we want to do that is because we want to get everything back into source control. That's the big thing about make files and cake and fake and all of these things. We get it back into source control, and everyone can read how things are built. We can check out an old version of the code, and we can see how the code was built at that time. So if we store everything in like TeamCity or VSTS, we just usually have, it doesn't like follow the code. We can have different revisions and stuff like that, but it's kind of hard to keep track of what build process and what build steps are belong to what revision of the code. And also, if you have a lot of branching and stuff, maybe you want to change how the app is built in a branch, and you do a pull request, you want it to build, but you don't want to change the build process for the other branches until this one is ready. So that's another like big win for having your build automation in the source control and together with the code, and not letting some external system control it or own it. And you get all the other things that you get by having things in Git. Like it's distributed, everyone has a copy, yada, yada. So I was thinking like, okay, so we're using a tool like this for builds, and I was thinking, why not use the same tool that the developers know for our deployments? And I got this email here on the left side, like this summary email from Twitter, and like, oh yeah, another of these build automation tools or utilities. And I'm pitching this term up here, which is ache. And it's like, there are so many to choose from these days. And as a .NET developer, you have basically these three options, which are the big ones. And I kind of wanted to just say that psake, which is PowerShell, sure, if you have a lot of PowerShell and your whole team is super awesome in PowerShell, you can use it. But if you're, in terms of features, in terms of contributors, and the way going forward, the other two are much better options. I can be as honest as to say that if you choose cake or if you choose fake, it doesn't really matter. You have to choose what your team is most comfortable with, because you can do the same with both of them. The reason I prefer fake is a personal experience that I've tried to start using cake in teams that are more C# focused and a bit hostile against F#. But I didn't have as good an experience in the editor and in the documentation. And that's why I'm falling back to fake, I feel, all the time. And the C# devs on my team, they are all very happy with F# make or fake. Also, I had to change some things with this talk because 9 days ago, the final release of Fake 5 Fake 5 came out like officially. It's been like a release candidate for some time, so I've been using it, but it's a bit yay because it has all of these things included in it. It's much more modularized. It's like a rewrite of Fake in many ways, so they've taken the good going forward. It's much more focused on the new .NET CLI tools, and it's even now with .NET Core 2.1, you get global tools, and now Fake is a global tool, which feels much more right than having to bootstrap it. I'll get a bit back to that. And yeah, it removed some needs that you had previously, but you don't need anymore. The reason I like Fake so much is because Fake is all valid F#. So as long as you have an editor that supports F#, then you have Fake working. You just need to define your modules in the start, which is still valid F#, though this syntax is Fake specific, it's still valid F#, so it doesn't break anything in your editor. And then it gives you this IntelliSense file that you load in. F# has been cross-platform and available on all platforms for a long time. It's also like scripting language down in its core. It didn't get like a CSX files like years and years after the language was created. It's very lean and nice functional programming language on the .NET stack, and that makes it perfect for script files. And it lets you load this IntelliSense file that Fake makes for you. And then you get auto-completion and compile errors, everything like you expect to have in your normal daily programming experience. You get that also in your build script. And I feel that this is, from my experience, much superior to the other build systems. So you do that. You set your modules or your dependencies, whatever you want to call them, and they are built independently and published on NuGet, and that's where it's getting fetched from. You take in your editor auto-completion, and then you define targets. And here are some very simple targets, like clean folders, build the solution, and yeah, just a default target. Because in a target, you can basically do anything. Anything .NET can do, you can do inside a target like this. And then in the end, all the way to the bottom, you have these arrows defining the order or the dependencies of your targets. So you're saying, to build, I first need to clean, because if I try to build, there might be a lot of old files in these folders. So it's kind of like a DSL, a domain-specific language, like that you're writing, the Fake language, but it's, again, all valid F#. So this target is like a namespace or module, and .create is a function that takes a name and yeah, another function. So all valid F#. There's a lot of finished module too, so you don't have to jump into a target and start writing like .NET code. There's a lot of like finished modules, and here's just an example of a lot of things you can do with Fake, kind of out of the box with the modules that are already there. Especially like things like generating assembly info files for this version that you're building, integration to TeamCity, and yeah, creating releases in Octopus Deploy. You can do almost anything with modules that are already there. So usually in a project, like a normal project in my team, the dependency graph in the bottom of the build.fsx file would look something like this. And what we're looking at here is like, the first is the simple one. To build the project, you need to restore the packages. And before you do all that, you need to clean. So I just established that, the first in the file. Then we have integration tests, and they become a bit more complex, because before integration tests are run, we need to migrate the database. And before we can migrate the database, we need to have created the database. And then we want to delete the old integration test database if it's there from before. And before we can migrate and run tests, we need the migration and the test projects to have been built. So they depend on build again, which again depends on restore packages and clean. Then we have three independent kind of targets that are all dependencies of the CI target. So if I tell Fake to run the CI target, it will see that these are not dependent on each other, so they can be run in parallel. And then the last step we have is the artifact step or target, which is dependent on the CI again. So when everything has run, unit tests, integration tests, everything, we're going to build an artifact. And I'll get back a bit to the artifact. So when I run Fake, it looks through my file, and as long as it's valid, it builds this dependency graph for me. And here you'll see that it will start all the way to the right with the clean. It will work its way up, but as you can see here, integration tests, unit tests, and this NuGet packages consolidated step are on the same level. So if you run Fake with the parallel command line flag, you can get the faster builds if you are a bit smart with your dependency graphs. So for example, this is a great example of a target that it's just pure F#.NET code. And you don't need to understand what this screen says, but you have to understand that this is like the same I would write if I was writing a command line tool to do this. And it basically just parses all the packages. This is a .NET framework target, and it just goes through all the package.config files in your solution and make sure that if you're using the same library in two different projects, they are the same version. You can achieve this by right-clicking on the solution in Visual Studio, choosing Manage NuGet Packages, and then go to the Consolidate tab. And you can fix that there, because that's not something NuGet enforces for you in .NET Framework. So I was like, OK, then we're going to stop this at build time, and we're going to make a build step. And it has nothing to do with the .NET CLI or MS Build or anything, just pure code because of a build step that we as a team decided this is important for us. And the same with the create integration test database step. It's simply this is the whole target, and it just calls a function or a static method for C# people. Like, it's nothing special. And that function, again, is just normal .NET code to create a database if it doesn't exist already. So nothing special here. And it's so nice to be able to write these things in .NET the day I use, the language I use all day. Sorry about that. So before .NET Core 2.1, you would still do it like this, because you would need a CSproj file to resolve this .NET CLI reference that you see on the bottom here. But luckily, with Fake 5, we can just cut this whole step and actually don't have this CMD SH bootstrapping stuff. Because with .NET Core 2.1, we got global tools for .NET. And now all you have to do is install the Fake CLI as a global tool. And then you can run with the simple command line Fake run build FSX. The .NET global tools are added to your path, so this is available there. OK, so very easy to run the Fake script as a developer on your machine. You just install the tool, Fake run build FSX. OK, but that's the easy part. Like, now we're thinking, how would we hook this up on our build server, like on TeamCity or VSTS or whatever? Well, not surprisingly, it's as simple as this. We add a command line step, and we do the exact same thing. And this is important. Like, now we're getting down to the core of why we want to build automation tools like this. The same thing that I'm doing to test the build on my machine is the exact same thing that is happening here on the build server. So if I want to test a change to the build, how the build server builds stuff, I can just do it on my machine because it's the exact same thing. I don't have to keep checking in thing and have this long feedback loop if I want to do changes to my build. The only thing we have extra here is this publish artifact out step, which is like VSTS specific in this case. So we're saying like, OK, we're going to get an artifact out of our build. You have to upload it to VSTS. Because VSTS, in this case, is like our artifact repository. That's what keeps our artifacts. And our artifacts, in our cases, we use Fake, and we also use it a bit longer further along in the pipeline, which we're getting to. So this is how our artifact looks. It has an infrastructure folder, which is basically just copied straight from the repository. And it keeps this Azure deploy.json, which is a Azure resource manager template. It's basically our infrastructure as code. And it doesn't matter if it's Azure or RM templates. It could be Terraform, whatever. It's just, this is the infrastructure as code or as data, whatever you choose to call it. We have this populate key vault secret file. I'll get a bit back to that. It's not that important now. So that's like the infrastructure. And then under that, you see we have this provision FSX and the FSX log file. The log file just holds some information about which versions of, most people here are probably familiar with log files. It's nothing special. It's just pins our version of dependencies and stuff. And then in the bottom, we have this app is called Weather. So here we have weather23.zip. So this is kind of what most people would consider the artifact these days, because that's the actual app. But our artifact here is not only the app, it's the infrastructure at the point of time this app was made to actually run it, and is also a script on how to put that infrastructure out and how to deploy the app to that infrastructure. Because this is all relevant to which version of this app it is. So we're building that all together, and the final artifact is everything you need to know to get this app into production or into a running state. The RM template is basically what you would expect if you've seen it before. Defines some parameters, some variables, like names of stuff, but it kind of bases the names on the name of the app. We make an app service plan, which is like the underlying resources. We make, in this case, an Azure website. And the important thing to notice here is that we give it some app settings. We give it a connection string, but as you can see, we don't provide the name or the explicit connection string. We just hook it up to another resource in the same file so that when this SQL server is made, it will insert the correct connection string. So I don't need to know the connection string beforehand. It will be resolved by Azure for me. And we add the database. We add the identity of our web app to that SQL server, so it has access to the server. We add a key vault, and here we also do the same. We add the identity of our app to that key vault, so our app can access the key vault. And we will end up with this when you run the file, which is a resource group with a web app, a key vault for secrets, a SQL server, and that's it. I'll get a bit back to the identity of the web app, but this is important that we are giving our app its own identity. So it doesn't have like a shared connection string or shared username or password that everyone can use to connect to the database. It has its own identity in Azure, in Active Directory, which it uses to talk to SQL and to Key Vault. So we get complete auditing. And if you want to be that, you can't be the app on your developer machine. Then you have to use your own Azure account, and it's very clear that you are the one accessing Key Vault or SQL Server. So a bit back to this provision FSX, because we have one prerequisite for that. And that is that you need the Azure CLI installed. And this is a prerequisite not only for you on your machine if you want to run the script, because of course the provision.fsx script that we have in our artifact, it runs the same on your machine as it does from any other tool. And this is also important. Like if I want to put up a new environment to see that the provision script actually works, I can do that from my machine, no problem. All I need to do is log into the Azure CLI. And this is like a new developer on the team. This is all they have to do. Make sure they're on the right subscription. And in provision.fsx, we have some like code that basically just wraps around the Azure CLI. And in this case, you can say it's maybe a bit overkill to just, why would I could just write a PowerShell file or something with this, like calling the Azure CLI. But what I notice is that this I can hide away in a fake module. probably going to do that, just contribute it straight into Fake. So there's a module for calling the Azure CLI. But what I noticed that if I was using PowerShell for that, I found it much harder to parse output from Azure commands. When I do it in F#, I can use the F# type provider to read the answer I get, which is JSON, and use the values if I want to keep using them further down in my build script or provision script. And also, basic things like checking if the parameters passed in is correct and everything. Is like I can use the same language for validation and all of these things as I do in my daily job, writing software for the company where I'm at. So that's kind of important, and that's why I think this like wrapping around Azure CLI was worth it. So a simple step would be something like this. Ensure resource group exists, because that's the one thing we need to have before deploying the RM template. So you see it's basically just a command. The AC is wrapped in here, but it just runs a normal Azure CLI command. Group create, location, the name is passed in as a parameter, and then I'm just querying the result that's built into the Azure CLI for the provisioning state, making sure that it succeeded, and then I'm just like saying, OK. And if it didn't succeed, I'm just going to fail it. So super simple. Then basically the next step, same thing, group deployment, parse some parameters to find the parameters files I want to use, because we have different parameters file depending on what kind of environment you are. So you can be a test environment or a production environment. We don't operate with the production or the test. So you have different parameter sets based on what kind of environment you are. And basically, it runs the Azure command, group deployment, create. If it succeeds, carry on. Same with the deployment of the app. It's just a bit of magic to find the closest zip file. This could probably be done a lot better. It's just an example that would work both on your machine, where maybe the zip file is in a build directory, while on the build server or the server running the script, it might be in the same folder as the script. So basically running this deployment with the zip file as a parameter, and of course, logically, if it gets the status code 4 back, that's a success. Makes a lot of sense. I guess there's some enum being answered there. So you end up having a provision FSX file that looks something like this. You make sure the resource group exists. You run the deployment of all which we saw in the earlier, to get the web app, the SQL server, the key vault. Then we deploy the zip file, the web app, to the actual web app. If the secret file is decrypted, I'll get a bit back to that, then we can populate the key vault. Then we do smoke tests, which is basically, in our cases, we just have an endpoint that we call for each app, and it's up to each app or each service or whatever itself to determine what determines if it's online and working. So we basically just know we're going to call this endpoint, and if we get a 200 OK, we're going to take the staging slot that we just deployed to and swap it with the production slot. So that's the last thing we do. When we see everything is working, then we switch production and staging slots. I'm not going to get into deployment slots, but people who use Azure Web Apps know about it, and you can check it out yourself if you want to know more. And of course, again, anything .NET can do, we can do in this script. And it's the same tool we're using now to provision and deploy our app as we're building it. We're putting this script back in source control. So if I check out an old version of the code, I still have the infrastructure, and I have how it's deployed. So I have everything I need to maybe test that version. And so how do we hook this up in our release management tool of choice? Because while I go to colleagues and friends and I say, like, I hate Octopus Deploy, I hate VSTS, like, don't use it, don't lock yourself into that. Of course, you should have one of those tools, because you need them for the centralized management of what artifact is deployed where. What I'm not a big fan of is putting too much variables, too much steps in these tools. And that's not only for the release tools like VSTS and Octopus Deploy, but also the same for TeamCity and build tools like You should source control everything. And these tools are getting, the release tools, they are getting much better at understanding that this is what we want. So they're letting you define your steps in the source control. And this is something you should be doing. And I've been in projects where we had like pages upon pages of variables in Octopus Deploy, and that's our own fault. That has nothing to do with Octopus Deploy, by the way. But it's so easy to get there because you kind of forget. You start relying on these tools too much. So this is an example of VSTS. It, luckily for us, has an Azure CLI step, which was the only prerequisite that we had, remember? So the same goes for the release tool as for the developers. You need this Azure CLI. And then, of course, the same familiar 2 lines. Install the fake tool and just run the script. Except here, it's worth to notice that we're working out of the root of the directory of the artifact. So we're like, we set the working directory to be correct. And it's also worth noticing that we pass in some parameters here. So here we say this is the test environment, and the app name, which will be the name of the resource group and the web app, we pass in from the release management tool. That means that it's, in this case, VSTS' job to keep track of what environments do I have running now and what artifact has been deployed in them. And that's the only job it has. It doesn't know anything about how to deploy. It just knows there's a script that I have to run. And if I want to add a new environment now, I just click the add button, give it a name, and click deploy. And that name will be, it will be that name.azurewebsites.net, and it will run the script. It will see that there's nothing there. It will provision everything, deploy the app, and I have an environment up and running. And since it's so easy, it's easy to hook up. Like if people do pull requests into the repo, you can basically just put some tool to run the provision with that, the provision script with that, the name of that pull request or something, and you can have an environment up and running with the changes in that pull request to review it, just delete it after. Like if you make provisioning and deploying this easy, it's very easy to put up new environments to test changes in the code. So here you can finally get some of the benefits that you get for free with containers and that kind of stuff with the platform as a service too. So this is important because this makes you able to stop thinking about environments. Because in a lot of projects, people are, of course, looking at environments as like a holy thing. This is the production environment. This is the QA environment. This is the test environment. But you shouldn't look at it like that. You should look at this is the entry point that my testers know about. This is the DNS, the address. Everything else, forget about it. If we put up a new environment, we just change the DNS. Don't be afraid to have environments that you can delete. The only thing that is important is your data, not the environment or the resources other than that. So just find a way to take care of that and then stop thinking of environments as something holy. So basically, if you're a new developer on the team, you come in, you set up your Azure CLI, install the fake CLI, .NET Global tool. You run build FSX, you'll end up with the artifact on your machine, and then you can just run provision FSX with some kind of like your username, dash company name or whatever, just to get an environment up and running that you can test and do stuff on. And this, of course, as we saw, is the exact same thing that the build server and the deployment tool runs. The only extra responsibility we put on the build server is keeping track of build numbers. It's just a centralized way of making sure that when we talk about one build number, we are all talking about the same artifact. And the second thing it's responsible for, in our case, is the artifact store. It's the one who keeps these artifacts. You don't have to use that. You can use myget or FTP server for all I care. Don't do that. But that's just the things that we want centralized. And then our release tool, of course, the only thing it keeps track of is which environment exists and what artifacts are deployed there. So what happens to this zip file? We're running this command. This is basically the command we're running inside provision FSX. So we have a zip file, and it's going somewhere. And where it goes is Kudu, which is the engine behind the deployments and everything for web apps. You can access it by going to Advanced Tools all the way in the bottom here on the left side inside your web app and clicking on this Go button there, or you can just add a .scm.azurewebsites.net to your address. And I know everyone who's ever worked with Azure Web Apps has been into this site. I'll just show it simply. It gives us information about our environment and gives us APIs to look into our environment. It gives us a debugging console, which is CMD or PowerShell. But I think they have Bash if you are using a Linux or container version. And here you can browse your files. You can look into them. If you don't have any log aggregation yet, or there's an error that's not there, you can go there and have a look. Write commands, and you can go in, you can check all the environment variables, what is in your path, make sure that everything is right. You can go in and check the status of your deploy and the output of your deploy. So you can see the actual things that were run during your deploy. So if your deployment fails, this is an easy way to just go in and see what actually failed. And of course, you have the REST APIs too, with a JSON plugin for your browser, super easy to browse through and see all deployments. And you can, of course, also integrate against this if you want to pull this and output it somewhere else on some kind of screen or inside some kind of tool. But of course, it's just not a web interface. Kudu is, as it says here, is the engine behind deployments and web jobs. And the cool thing about Kudu is open source. It can run on your own machine. I actually had it up running on my own machine and to test stuff because it was a much faster feedback cycle where I was just getting to know Kudu. It lets you deploy in different ways, not just Git and HD deployments, but it also lets you deploy via FTP. You have the good old MS Web Deploy, which it lets you do. And it can, of course, connect directly to GitHub or Bitbucket and these kind of places and pull changes from there. And you can either deploy a zip file with files ready to deploy. You just say, copy this into the folder and serve it. Or it can discover, if you if you have a .NET app in a GitHub directory and you connect it with Kudu to your web app, then it will discover this is a .NET app, and it will have a script ready for building it and copying the correct output files into the web app. And of course, it also lets you run custom deploy scripts. It uses a tool called Kudu Sync, which basically takes files from a staging area, files that has been staged, and copies it into the production folder. And it's just a kind of diffing tool that makes sure that old files are cleaned up and new files replace old files. The only thing worth noticing is that you use this tool if you write a custom deployment script, but it works on your machine. It's just it's on NPM, and it works just the same on your machine as it does inside of Kudu. So I guess you see where we're going with this. We have a tool that can run on our machine. We have a custom build script feature where you can add a .deployment file in the root of whatever you're deploying, and you can call whatever you want. I guess you didn't see that coming. But it's the same two lines that we've been using for build and provisioning. But now we're going to use it for deploy. The only difference here is that they don't put the global tools in your path because of security stuff, but they always put it in the same place. So that's why we have the folder underneath there. It's always going to end up there, never anywhere else. So yeah, cool. Now we're going to write a deploy script. But why would we want to do that? Well, the big win about running this script inside of Kudu is that we're actually running it inside of this Kudu sandbox. We're running it in the same place that our app is running inside the same sandbox. And that means that we will have the same configuration. We will have access to the same environment variables, the same connection strings, and the same identity, which means that inside this script, we have all these things available to us. We can act as the app with all the accesses that the app has, and we have things like the connection string. And that's when it starts getting interesting, because then I don't need to have my connection string in my deployment tool as a variable inside of ESTS or Octopus Deploy or whatever tool you use, because the app has the connection string. So if I need to use that to migrate my SQL database, the script just needs to know that it has the name of the connection string. So basically, you can get a step like this, where our migration tool is just a console application that takes a connection string and a token. I'm using some, which I'll get back to, built-in or Azure libraries to get access token as the identity of the web app. And I'm using that token together with that connection string to migrate the database. And since I'm doing this inside of the Kudu sandbox, I have all these things available to me. And I can migrate the database without having to provide a variable set with all the different environments I have. What is the connection string for that? What is the connection string for that? And I don't need to administer that at all. It's up to each environment to know where their database is. We can talk here about security aspect of this, which is totally solvable if you feel like it, because to migrate the database, you need to be able to create tables, for example. Maybe you don't want the user of your app to be able to create tables. So you can go around this by giving your app two identities, one for migrations and one that is, So solvable, but I'm not going to cover that here. Important thing is here that we just removed all the knowledge about doing this kind of deployment things from our deployment tool. But it's important to know that the last thing we did is swap the staging slot for the development slot earlier. So if we're doing this, and this is the case not only with Fake, but of course with any deployment tool, that you might migrate your database and then the actual deploy fails, and you never put the code into production, but the migration has been run. Well, there's a simple answer for that, and a lot of people are wondering how to solve that problem or talking about it. It's just always be backwards compatible. The easiest example of that is if you want to remove a column in your database or in a table, then you don't deploy the migration that removes the column and the code that stops using it in the same deploy. First, you deploy the code that stops using the column, and when that's working fine in production, then you do another deployment where you delete the column. So 3 steps. Because then if the removal of the column happens, but the deployment fails, you still did a deployment before that stopped using that column. Puts a lot of pressure on a development team going fast, but if you're using SQL migrations because you're using a relational database, that's how you have to do it to be able to deliver continuously and don't break stuff. And basically, the same thing applies to Cosmos DB and document databases. Like you have to be compatible with if you're changing the schema and stuff like that. Your app has to be backwards compatible to support that, of course. This might be obvious. I just thought I'd mention it. So I wanted to go like a bit back, and because I'm talking a lot about identity here, and why you should give your application one, because you should. And it's all about, because we're talking about Azure Web Apps here, and Azure has great support for role-based access control built into Azure. And it has the ability to give, to make app registrations or service principals and all this stuff, where you can give your app or your resource in Azure its own identity. And that's because you don't want to have an SQL database with a username and a password that everyone is sharing around You want to know who is accessing that database, and you want to be able to give them certain credentials or permissions in that database. And we're doing that for like our developers on our team. We all have like different accounts to log into VSTS, whatever. And we should also, if I'm working on an app that uses Key Vault or SQL Server on my machine, then I should use my Azure account and have permissions set to my account on those resources to access it, so that the accesses are correct and so that auditing is correct, especially now with GDPR and everything, in case there is personal data in those resources. It's easy to give an app an identity. One team I was in, we started it very easy way. We made our own certificates, private public key. We made our own service principals in Azure, uploaded the public key there, uploaded the, how we did it isn't that important. Provisioned the private key to the app, so it had the private key and could authenticate itself as that service principal. But that's like the total unmanaged way to do it. Then you can also go a step further. You can do it partly managed, where you can have Key Vault create, or when you run the command to create the service principal, you can tell it to, here's a Key Vault, create a certificate for me and put it in Key Vault. So then you have it partly managed, the identity of your application. But you still have to run that command to create that service principal. Well, now this is the new thing, which is I think it's still in preview, but I think it's going to be out soon. And this is what you're going to start using if you're using Azure. Managed service identity is a fully managed way to get an identity for your application, but not just web apps, but also SQL servers and other resources in Azure can get their own identity. And it's fully managed. You don't have to create anything, any service principal. You don't have to create any certificates. Renew any certificates. It's all done and handled by Azure. You don't have to think about it at all. Fully managed. All I do in my RM template is just say on my web app that, hey, I want an identity, and I want it to be system assigned. The output would then be this. So I get the tenant ID, which we're not doing too much multi-tenant stuff, so it's usually the same as the web app and everything else. But we get this principal ID, which is kind of the username of the app. So when I create this web app, I get this as an output. And then further on in my RM templates, I can basically say, hey, make an access policy for this Key Vault and put the identity of this web app inside of that access policies. So when this Key Vault then is made, my web app will already have access to read from it. And I haven't done anything about users or identities here other than tell it to referencing the web app that is made further up. And then if I go inside my Key Vault, I will see that I have this, in this case, the application's name is Weather in Harstad, because who doesn't wonder about that? So I can see that's been added for me, and I don't have to hook up my web app to the Key Vault anyway, in any way. And here is an example of using this Azure Services App Authentication Library together with the Key Vault library. So this is like inside of this red square here. This is all I do to get an access token. And that's because the MSI, what it does, it puts up like a local host endpoint inside the web app that the web app has access to, which is kind of like a token endpoint, like OAuth style. And it just calls this endpoint with some client ID and stuff that it gets from variables, environment variables, and it gets an access token back. So this is how it authenticates. And then you're asking, will this work on the development machine? Because I'm all about this whole talk. I've been about, I want things to work on my machine the same as it does in the cloud or on a build server and stuff. And yes, it will. This library first goes to this managed service endpoint. And if it doesn't find access token there, it doesn't manage to find that endpoint, it tries to get it from Visual Studio, and then finally from the Azure CLI. So if you are logged in, which is anyway the prerequisite for all our developers and all our tools, then you would get a token there. So you could run this app basically as long as you're logged into the Azure CLI and be authenticated and call the Key Vault. So how do we populate the Key Vault with secrets that are not generated in Azure? We get a lot of, like, maybe we get certificates or we get secrets from other teams or whatever. It happens. What we've started doing is also source controlling this for the same reasons that we source control our build steps, our provisioning steps, and our deployment steps. We are also putting our secrets. You can do that. You can have a script that does it, which we do on some apps. We don't have too many secrets like this. We try to have everything inside of Azure that talks to each other, managed by Azure. So this is just third-party services. We'd maybe have it like this, where I just insert it into the Key Vault and then update the corresponding web app with app setting pointing at that Key Vault URL. Or I wish I could have a nested template doing this. I could have it in the main template, but nested templates in RM templates is, sorry to say, shit. And this would just work with Terraform. But basically, to have nested templates in RM, you need to have them publicly available on the internet. You can't like ship them up and do a deployment with them in the same folder or something. Your main template has to reference it with like a public URL. So yeah, keep your secret source control and provision them like everything else into Key Vault, because the secrets change and you want to have them together with the app, the secrets that were belonging to the app at this exact time. Same as with provisioning and everything. But of course, the big question, what everyone's wondering now, you don't want to put secrets in Git open for everyone to read. Of course not, and I'm not saying that either. This is not an endorsement of Git Secret, but Git Secret is very easy to use, where you have a GPG key, which is not easy to use, but that's another story. Still waiting for the next evolution of being able to identify myself securely on the internet. But basically, Git Secret, there are other tools like this. You have GoPass and just Pass, the Unix password manager. A lot of tools like this that you can use for sharing secrets among your team, but also for populating, for example, a Key Vault. Basically here, I'm adding a file as a secret. I'm telling myself, in this example, or someone else, I have the public key of in my keychain. I then run this hide command, which makes this .secret file of that file I wanted to hide, and I make sure to add the real file into git ignore. So that means I can, when a new developer comes on the team, I can basically just run this git secret tell after I gotten their public key, and then run the hide command again, and then they can decrypt the key as long as they have the private key belonging to the public key I got from them, which I hope they do. So, of course, this puts some more demands to knowledge about like keys and crypto on developers on your team, but they should know this stuff anyway, so that's no problem. So basically, a new developer comes on the team, he can just run git secret reveal, and it will reveal the secret files as long as they have access to that. And when somebody leaves the team, you run this kill person command, and it's a nice command. And then they are basically removed, and you encrypt the files again, and they can't access any files from that day onward, because you don't want to somehow remove them back in time, because they can anyway have written down the secret. It doesn't matter. You just want to make sure that from now on, they don't get any access. So that's an example of how to do it. And I think it's really worth looking into this. You don't want to have you want your secrets to get all the benefits of Git, which is that it's distributed and that it's version controlled, yada, yada. So basically, this is where we arrived. 3 simple scripts that can all be put in source control, all using the same tools, the same language, the same libraries. We run build FSX for the artifact, provision to get our infrastructure and actually putting our app up in the cloud, and we run deploy FSX for actually doing things that we want to do in the context of the application, as migrating the database, maybe getting a secret from Key Vault to use for something, up to you. And all of these scripts are runnable from the developer's machine. All he has to do is log into the Azure CLI, and he can run all the script, including deploy FSX. He can use that to migrate his own database on his own machine to see that it's actually working. He can see that the files staged by this Kudu Sync application and ends up in the final folder are the correct files. So everything that Kudu does during the deploy inside of deploy FSX, the developer who makes a change to that or is testing something new can run on his machine and see that it actually works. None of these scripts will give you an error if you run them on your machine. So the same as before, showing like a new developer on the team, he can run deploy FSX if he wants to on his machine, but it's of course inside this zip file that we're pushing up to Azure, and it's getting run there. And these files doesn't have to be Azure specific either. Like, you can just say that this is how we want to do it in our team, no matter if you're using, I don't know, containers or if you're deploying to, we're doing the same thing to virtual machines too. And that's actually important to know, that then this managed service identity is also available for Azure VMs. So you can get an identity for inside of your VM that your apps running there can use. But we do the same thing. It's just that inside of the deploy FSX script, it's not this Kudu Sync and stuff. It's just inside there, we actually just do, we take our IIS page and just point it at another folder. So that's how we do the same procedure, but to a VM. It's just that inside of deploy FSX, it's VM specific, like setup of IIS. Not setup of IIS bindings and stuff. That doesn't belong in deploy FSX. That belongs in your provisioning script. So just think of also disaster recovery and how easy all this thing is. As long as you have your data, disaster recovery is almost covered by this. It's very easy to practice, at least. You don't have to, you have everything ready. So you can check out Fake at fake.build. There's also a link here, Nikolaya at Weather in Harstad, which is an example repo showing almost all of this stuff. I wanted it to show, let's see. Which basically is a secret, it's not a secret anymore, at least. It's an example app showing these things that I showed you today. Almost all of them. It doesn't have the migration stuff, since that was .NET Framework specific, and I haven't moved it here for people to see. And of course, you're not getting any secrets because they are encrypted here. It's just a simple page showing the weather in Harstad from different sources. It's kind of cool project. Check it out. It uses F# type providers on .NET Core to integrate to different services and stuff. So that's if you want to check it out. And that's it. Thank you for listening.